the exponent, anything to the 0 power is actually equal to 1. So you put a 0 in, 0 is your x coordinate. That's going to make b to the 0 equal 1, and then 1 would times a, and your output then would be a. So that y-intercept is always going to be the value of your a. And in situations that we're going to look at today, like this 980, the 980 is kind of like the starting point of your exponential graph. And that's kind of where your y-intercept is. Next is b. B is your growth or decay factor. And we see a growth or decay depending on how your percent or how your number compares to 1 or 100%. So a growth is any time you have a percent greater than 1. So 1 plus r, where r represents your rate, your percent rate. And a decay happens when you do 1 minus r. Now, it's important to know that your 1, that represents 100%. If your growth or decay factor is 100%, that would mean that your outputs would just stay the same. They would just constantly be the exact same. When you increase by a certain percent, so if you go above 100% or you add on a certain percent above 1, that's going to start to show a growth, and you'll see your graph start to grow as time goes on. A decay happens when you subtract a percent from 1. So if I'm decaying, we start to see our graph decrease as time goes on. So if you watched your instruction video, you would see an example of a growth and an example of a decay. Remember, a nice program to use is Desmos. You can throw in equations into Desmos. So y equals 2 times 1.2 to the x power. So there's an example. Since I'm greater than 1 in my b is greater than 1, I'm going to start to see a growth as time goes on. So your b value starts to determine whether or not you have a growth or a decay. So that's what we are going to start to focus on first. So do we have a growth? Do we have a decay? And then what is that percent increase? So I'm looking at first, I've got y equals 980 times 1.08 to the x power. And I'm focused on my b value, which is right here, 1.08. And all I'm determining is 1.08 greater than 1 or is 1.08 less than 1? Well, it's greater than 1. So this one is going to be a growth, which I've already have. That's the default answer there, growth. But what is the growth? Well, the growth is what percent is it above 1? So here it's 1.08. So that would mean that it's 0.08 above 1. Now 0.08 right now is a decimal. To change that to a percent, I would need to move it 2 to the right. So 0.08 as a percent is going to be 8%. So I'd put growth, and then my second, what percent increase is that? That's going to be an 8% increase. So again, the 980, we are not worried about the 980. That is the y-intercept. That's where this graph would start. It would start at 980, and then it increases at 8%. All right, and then there's our kind of rundown of what we're looking at. So what I used is the 1 plus r. So then I just looked at, well, what does r need to be to get from 1 up to that 1.08? And we got an 8% increase. So this example could be an example of like finance. If you invest $980 and you get an 8% return per year, this is an equation that you could put the amount of years in for X. So maybe 10 years down the road, 20 years down the road, you could go and see how much growth your $980 would have. So we're going to start continuing to look at situations also that represent that. Let's see if we can get a decrease. Here we go. So now I'm looking at my growth or decay factor. I'm looking at my B, and now it's 0.3. Now, a common mistake would be that I just put my growth factors 30%, or excuse me, my decay factors 30%. That's not quite how it works. This is 1 minus r equals 0.3. So what do I need to subtract from 1 to get to 0.3? Well, r would have to equal 0.7. And change that to a percent, that's going to be a 70% decrease. Okay. So we head back to, we're going to change this to a decay, and that's going to be a 70% decrease. So examples of decay, a big one would be in science, you talk about carbon dating. So as live things die, so like humans or animals or plants, as they die, when they die, they start to lose carbon. And then you can figure out after, I think it's like 5,800 years, a living being that's dead will lose 50% of its carbon. So then you can kind of test how much carbon is left, and then you can kind of see how old that dead thing is. But we would start to see that decay, so that carbon is decaying over time. Another situation would be like purchasing a car. When you purchase a car, the value of that car decays. Special cases where you buy maybe a collector's car and you keep it in good shape, it might increase after time, but most of the time your car is going to decrease in value each time. So here we're saying our $2,600 is only keeping 30% of its value, which means it decreased by 70%. And then there's how we can find our decay. So that's our first order of business, is just getting used to how that growth and decay value work. Next, looking at some exponential functions. So here we're now going to start to place values in for A, value in for B, and then start to calculate our Y according to our problem. So here we have $4,400 is deposited into an account with an annual interest rate of 8.25%. So that would be my R. How much will be in the account after 22 years? So A is going to be my 4,400. That's like my starting point. So in these situations, whether it's the value of an account, the amount of money you spent on a car, wherever it starts, that represents your A value. And then the 8.25%, that's going to be my rate. And then 22 years, that's going to represent my X. So my X is going to be 22 years. Now, it's important to know when you invest money and you get this interest rate means it's a growth. So it's growing 8.25% each year. And when finance institutions, when they use percents, they're going to change that back to a decimal. So this would be 0.0825, which then tells me my B value is going to be 1.0825. So remember, if you have a growth, you're going to add that to 1, because 1 is like your 100%. Add that 8.25% on, there's going to be my B value. So now if we look at what we've collected here, we've got an A, we've got a B, and we've got an X. So now we can start to write our equation. Y is going to equal 4,400 times my growth rate, 1.0825, raised to 22 years. So there would be our equation. And I'm going to use my calculator, and I'm just going to use my handheld. If you need help with how to do powers, I'll try to explain it here, but we got 4,400 times 1.0825. And then to hit the exponent of 22, you're going to hit the caret, which is above divide. And then you hit 22. And we should get, it's going to be worth $25,169. And then it goes 0.0363. Anytime we're dealing with money, we're going to round to the nearest cent. So since it's a 6 after that, we're going to go up to 4 cents. So my final answer should be 25,169.04, because that 3 cents has a 6 after it. It's going to round up to 4. And then we hit enter. And there will be our rundown of what we just actually did. So it kind of shows you the power of investing money. There is no amount of money to invest too small. If you start an account at a younger age, you can definitely see exponential growth. Like I was your age once back in 2002, and I was actually just looking up the stock price of Apple back in 2002, and the stock price of Apple back in 2002 was between like $3 and $4. And now the stock price of Apple is $140. So you can see that as time goes on, that increase is exponential. So if you would have bought 1,000 shares of Apple back in 2002 for $3,000, $4,000, it would be worth definitely over $100,000 today. So you can see how that grows rather quickly. That is it then for our Delta Math. We are at 10:01, so that is all I have for you today. Today you can then take a look at lesson 7.2, and we'll come back. We'll start looking at graphing using the H and K and so on and so forth. But you are free to break off to work on your own. I will stick around for any questions that you have, and have a great day. And if you have any questions, stick around.